Hello, maurieo! In this video I'm going to take a look at calculating support reactions. Calculate the support reactions for the following beam. Well, let's have a look at the beam. The beam is in red, support reactions in red at each end. We have a point load of 20 kilonewtons 1 meter from A. All measurements have been taken from A essentially, so that we're going to calculate moments about A in this instance, first off anyway. We have a UDL, a uniform distributed load. You could see my video, what the hell is a UDL, give you a bit more information about that. And the UDL is 6 meters long, and it has a load of 8 kilonewtons per meter. And then we have a further point load of 15 kilonewtons, that is. I'll just edit that out on the hop here. Kilonewtons is a force, kilometers of course is a distance. So we'll just put the big N in the magenta color in there. Might be a bit large at this stage text wise. There we go. Kilonewtons, that's that edited out now. A point load of 15 kilonewtons, which acts at 6 plus 2, 8 meters from A. And then finally we have the end of the beam 3 meters further on from there. So the first thing we have to do is look at the UDL. Now, how we deal with the UDL is we work out the total force, which is obviously the length times the 8 kilonewtons per meter, and 6 eighths of 48, and that acts about the center of the UDL, the uniform distributed load, which is 3 meters from A, it being a 6 meters, so it acts about its center. So that just gets treated as a point load, acting about its center 3 meters from A. And I've put that up here, acts about its center, 48 kilonewtons. So that's the UDL dealt with now. So we come to our two essential equations that enable us to work this out. So we know that the sum of the upward forces is equal to the sum of the downward forces. So RA plus RB, the upward forces, is equal to the sum of the downward forces, which is the 20 kilonewtons plus the 48 kilonewtons we've determined for the UDL, plus the 15 kilonewton point load, and that adds to a total of 83 kilonewtons. So RA plus RB equals 83 kilonewtons. Now we need to look at, if we take a moment about any point, it doesn't really matter where it is, but we're going to choose the moments about A, because we know that if we take A as the that will eliminate A or RA from the equation, because RA will have no effect in terms of a turning force, so we can eliminate that from the equation, and just then we will only have RB. So, and there are other videos around that indicate this whole thing. So about RA, we've got the 20 kilonewton force acting at 1 meter, the 48 kilonewton force acting at 3 meters, the 15 kilonewton force acting at 6 meters plus 2 meters, and that will be equal to RB acting at 6 plus 2 plus 3 meters. RA, of course, has no effect because that is the pivot point, so it's acting at a zero distance, so that gets eliminated at this point. So just working through those, we get our 20 kilonewton meters, our 144 kilonewton meters, 40 times 3, and our 15 by 8 120 kilonewton meters equals RB times 11 meters. So RB will then equal 284, which is the sum of the 20 kilonewton meters, the 144, okay, which gives us 264 284 kilonewton meters, divided by the 11 meter arm or length that RB is acting at, and that is equal to 25.818 kilonewtons. See how the meters cancel out there, and we get kilonewtons. So that's a force RB acting there, and it's come out in kilonewtons, so the units are good, so it's probably a force, and yeah, looks like it could be alright. Now we can calculate RA from our previous previous equation, because we know RA plus RB equals 83 kilonewtons, so RA will equal 83 kilonewtons minus RB. 83 kilonewtons minus 25.818 kilonewtons gives us 157.182 kilonewtons, and that is RA acting as it does there. Now, if you wanted to do a further check on this, it would be a fairly simple task to work out the moments about B rather than A. So you could, just as we worked out the moments, the clockwise and the anti-clockwise about A, we've got sufficient information there to work it out about B, so that would eliminate B from the equation, and we could calculate A. And well, I'm pretty confident that if you do that, you would get 57.182 kilonewtons. So there we go, the support reactions of the beam calculated.